Hello, geometry students. Today we are looking at an area review. This week there's only one assignment, so let's just take a look at it now. We're going to begin with area of a triangle interactive. We're going to drag the yellow point till an accurate height of the triangle is drawn. Afterwards, we are going to fill out the empty boxes to determine the area of the triangle. Let's see. What is the accurate height going to be? That is going to be where there is a right angle between the base of the triangle, which is really any side, and the third vertex. So if you draw this straight down, we're going to hit here, go across, then the length of the base is going to be 3.8, even though the yellow dot goes up to here, and the length of the height is going to be 7.29. Because the 7.4 is this side of the triangle. Be careful that we look at the blue number, which is 7.29. The area is half of 3.8 times 7.29, because 1/2 base height is the triangle. So we are going to go ahead and plug that in, and it's correct. Shocking. It's pretty easy. All we need to do is find the accurate height by sliding it along till, boom, we see that right angle. Base is going to be the side that we just T-boned into. So we got 7.3, 3.09, half of 7.3 times 3.09. That's all we had to do. Basically do that 5 times. The area of a triangle interactive is pretty easy, as long as you can follow that. Area of triangles. The area is 33.12 square inches. What is the length of the base? Now, the area of a triangle is 1/2 the base times the height. Since we're dealing with a right triangle here, we can simply double this and divide it by the height to get the base. So we got 1/2 base times height equals area. Meaning, you can take that area and double it to get base times height left over. And then we can divide by height to get the base. So all we're going to need to do is we are going to plug in 66.24, so 33.12 times 2, and divide that by 7.2. We're left with 9.2, and that should be exactly what we need. Perfect. And if we're looking for the area, we multiply the base times the height. So 10 times 5, you may already be ahead of me here, divided by 2, and you've got the area. So 25 is half of 50. So it's 6.12 times 2, because 1/2 base height, so double that. Divide it by the height, and you get the base is 3.6. Otherwise, if you knew the base and wanted the height, you would do the exact same math, because base and height are interchangeable for a triangle. If we knew the bottom length here and we just wanted to find the vertical length, then we would do the same calculations and we would find the same number answer. Let's hop into the next bit. Area of composite shapes, or composite shapes, either one. The grid you see below is part of in the shape of a rectangle. What is the area in square units of the shaded part? So a unit is going to be one of the square sides. So it's 4 units tall, because 1, 2, 3, 4 squares here. 5, 6, 7, 8, 9, 10, 11. It's 12 squares wide. So 4 times 12 is 48 square units. And if we actually counted them, we'd see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, all the way up to 48 of these things. Half of them appear to be shaded because we've got a diagonal running the whole length of the triangle, or the whole diagonal of the rectangle, and the bottom half of it is shaded. So it's going to be half of that base times height, meaning we're going to be dealing with 24 out of those 48. That's why, by the way, that a triangle is the half of base times height. Because if you count 12 times 4, you're going to get 48, which is the base times the height. And that's how many squares are actually making up this triangle. And of course, or the rectangle, my mistake. And of course, the triangle is half the rectangle because we literally just split it in half. So 1/2 base times height of that is going to be our area. See? Just like the note says. Next problem. Okay, so here we've got rectangle and a couple of triangles on deck. We're going to want to split this thing apart. So 7.6 times 6.2 over 2. That's going to be the right side of the triangle. We are now going to add 6.2 times 7.8. That's going to cover the rectangle. And finally, we're going to add 6.2 times, we're going to use some parentheses here to get 14.7 minus 7.8 in order to actually get the length remaining of the left side triangle. And that's going to be divided by 2 because 1/2 BH. And this number that we get down here, 93.31, is going to be our exact value for the area of this trapezoid. Perfect, we got it right. So we can split it up into the component shapes, namely triangles and rectangles, and solve from there. And we want the shaded part of this next one. So we're going to treat this like, instead of a crazy shape that's a trapezoid on its side, we're going to treat it like a rectangle stuck to a triangle or a rectangle minus a triangle. Either way is going to give us the same thing. So if we were going to do the stuck to a triangle, we would do the 5 times 18 that we would get from this top part that's going to be slicing all the way across if you follow the cursor across the screen. And we're going to add it to the bottom half, which is going to be half of the remainder of the 10. So 10 minus 5 was 5. So half of the 5 times 18 below. So plus 5 times 18 over 2. That gives us 135. You said that we could do it by subtracting a triangle. So that's what we're going to do. We're going to pretend this whole rectangle is going to be our initial shape. 10 times 18, 180. Now, you could all agree that if we took away the 5 from the shaded portion, from the 10 for the entire side length, we're going to get 5 left over because 10 minus 5 is 5. So we are going to calculate the area of the unshaded triangle. We're going to do a 5-inch base because it's half of that 10. An 18-inch height. Well, I guess you could do 18-inch base and 5-inch height because it's on its side, but triangle doesn't care. So we're going to subtract 18 times 5 over 2. What do you know? 135 is the same number we got last time. Let's plug that in. Basically, as long as you can break it into triangles and rectangles and know what to do with those, you're going to be A-okay. Let's do surface area from a net. Let's see how that works. So, Jackson wraps a gift box in the shape of a right rectangular prism. The figure below shows a net for the gift box. How much wrapping paper did he use in square centimeters? So this, we're going to actually have to break this into smaller pieces. Each of these is going to be a rectangle, and you're going to need to have a little bit of object permanence from the other pieces. So you're going to have 2 sides of this thing that are going to be squares, namely the top and the bottom. Well, my mistake, actually. They're not squares. They're just wider rectangles than the ones before. They're going to be 14 centimeters wide and 13 centimeters tall, as you can see from the labels. So we're going to do 14 times 13, but there's also one right here, so we're going to have to do the same thing that way. So this is 13 centimeters tall and 14 wide. Now we've got 4 pieces left over. 2 of them are going to be 9 by 14s, like this one and that one, the ones that have the red circles. 2 of them are going to be 9 by 13, like this one and that one. So we're going to do plus 9 times 13 times 2. plus 9 times 14 times 2. We get 850 square centimeters, and we're going to plug that in to our answer blank and see how that works. Basically, you break it into the little rectangles, just like it says. Top rectangle, side rectangle, bottom rectangle. Notice that the full diagram has 2 of each of those. Add them all together, double them, and you're good. So when we're doing these net problems, we need to break them into symmetrical pieces because they're going to be little copies of each other from time to time. Square pyramid is going to mean that it's got a square base and all 4 of the pointy sides are going to be the same shape and dimensions. So if we know the way to calculate this triangle, meaning 3.4 for the base times 4.4 for the height divided by 2, that's one of those triangle areas. We're going to have to multiply that by 4 because there's 4 of those things, like namely 1, 2, 3, 4. And then we're going to have to add the square with side length 3.4. So 41.48 is what we get whenever we add those things together. We nailed it. I imagine these are all going to be fairly similar, but just you got to make sure you break it down into the pieces. Make sure that the dimensions of the pieces line up with the actual numbers, and then solve them. None of the math is too complicated, but if you have some trouble with figuring out how the shape folds up and how the dimensions align, just let me know, and I'll do my best to explain it in class. So let's check out the last 2. Area of a circle rounded. The diameter of a circle is 7 inches. Find its area to the nearest tenth. Diameter is twice the radius. Area is pi times the radius, which is going to be half that diameter, squared. 38.48 rounds to 38.5. Nailed it. That's pretty much all we're going to need to do. Find the area to the nearest tenth. Heck, we're not even going to need to change this function here, aside from the number in the middle. Note that we don't have diameter anymore, but radius, so we're going to put in a 5. So now it's 78.5, because that's the numbers that we're given. Now we have the diameter, so now we're going to do 4 over 2, 12.56 rounds to 6. It's pretty much all it's going to give you. If it ever gives you the area, then just divide by pi and take a square root to find the radius. It just comes down to rearranging some simple algebra. Let me know if you have any trouble. And then finally, we're going to look at the last section, area of irregular shapes. Probably the toughest one. There are loud people. That's okay. So find the area of the figure below composed of a rectangle and one semicircle with another semicircle removed. Round to the nearest tenths place. So one kind of neat thing that I'm immediately seeing is if we were to cut this semicircle out. So, circles are all the same shape if they're all the same size. Meaning, since this one has a diameter of 8 and this one's on the same rectangle, it must also have a diameter of 8. Which means the semicircle that we cut out of this part should be exactly enough to fill the part we put into this part. Meaning it's the same semicircle that's cut out and added. So the area should be equal to as if you hadn't taken anything out of the rectangle at all. We could calculate it by removing 1/2 of pi r squared and re-adding 1/2 of pi r squared. But if you can quickly notice that the shape we remove is the same as the shape we add, we can just calculate the area of the rectangle and get our 80. This one is also a little tough. We have the radius of our semicircle shown. The diameter is going to be the height of the rectangle. So we're going to do 7 times What's 2 times 3? 6. That's going to give us the area of the rectangle. Now we're going to do 1/2 pi r squared. We do regular pi r squared, but that'd give us a circle, and semicircle means half a circle. So we're going to do pi times 3 squared divided by 2. Round to the nearest tenth. 56.13 rounds to 56.1. That is going to be this shape. We're going to continue getting weirder and weirder shapes. Actually, we might not get shapes that are that weird. Again, if it's a semicircle chopped out and a semicircle added on to the same rectangle, we can just calculate 15 times 8. But basically, you're going to be given, okay, so this is a square with 4 semicircles. So 24 times 24 plus half of 24 is 12 pi. Well, pi times 12 squared. It's only half of that because it's a semicircle, but times 4 because there's 4 semicircles. If you're quick-witted here, you might see that divided by 2 and times 4 means there's only 2 full circles. But if you want to just do it by the 4 semicircles, you'll still get the right answer. So as long as you can calculate the square and each semicircle and the number of semicircles, then you're going to get 1480. 0.77 rounds to 0.8. And it's not really too bad. So I'm going to let y'all run with the rest of this stuff before my laptop dies. But let me know if you have any questions in class, and I will get to you ASAP.